Today we're gonna remake Pong using the Rust programming language. Let's freaking go! I recommend you to have at least a basic understanding of how to write a basic Rust program before watching this video. Here are things you should probably understand before watching this video.
Let's create a rusty Rust project using cargo in the command line. Cargo init and then the project name. I'm gonna call it Rusty Pong. I know, it's so cute. Okay, we'll immediately set up the dependencies we'll use, so open up cargo.toml. For this game project we'll use a framework called GGEZ. It handles windowing, rendering and the game loop. We'll also use a crate called rand. If you need randomization of numbers, this is pretty much your go-to crate. Before we start writing code, it's a good idea to build a project because the dependencies need to be downloaded and compiled. And the first time doing that could take a few minutes. Cargo build. Great, let's write some code while it's compiling. Let's bring the libraries we need into scope. We need a game loop and that's what we're setting up first. Let's change the return value of the main function to return a game result. Game result is what GGEZ uses to handle failures or errors. We need GGEZ to give us a context so we can render things to the screen. And we'll use the context builder. We can use this builder to set up a bunch of configurations for all kinds of things. By the way, documentation is your friend, always keep this bad boy up when programming. The new function takes a game ID and an author. I'm not sure what difference this makes, but let's call it snake_0 and Tantan for now. It doesn't seem to matter.
Well, obviously it doesn't seem to matter because we're not making snake, we're making Pong. Come on, Tantan. Oh man.
Let's build a context using the context builder we just made. The build function returns a tuple. The tuple holds a context and an event loop. You might notice we are using a question mark operator here, and it's because the build function can fail. If you're using a really old graphics card, for example, then GGEZ will fail to initialize. If the build function fails, we'll crash the program gracefully. That's what the question mark does. Let's set the title of the window. This function requires the context we just created and the name of the window.
Snake? Really? Come on, Tantan, come on.
Don't forget to include the graphics namespace. Okay, let's see what happens when we run this. But wait, before we do that, the main function now returns a game result. We need to return a game result. Let's just return an OK at the end of the program. Let's start our amazing game. As you saw, a window was created, but it closes. We need a game loop. Let's make a structure called mainState. It will hold all of the game data and it will handle our game loop. Let's create a function called new so we can instantiate this struct. Then let's create an instance of this mainState struct in the main function. Let's kick off the game loop. We'll be using GGEZ event run. It takes the context, the event loop, and the mutable reference to our struct. Don't forget to include GGEZ event. Is that it? No! MainState struct needs to implement the trade event handler. Let's implement the update and draw function. I forgot to set the mainState to be mutable, so let's fix that. Bam, we have our game loop. Not too much interesting is happening, but we are now ready to implement some cool things. Let's jump into the draw function and call graphics clear. Pass in the context and the color. Before we can observe this fancy color, we need to call graphics present. Wow, that's majestic. You're doing great. Let's get a ping pong racket on the screen. We create a rect using graphics rect new, pass in the x and y value, then the width and height. To draw this rectangle on the screen, we need to generate a mesh. Let's make a mesh using graphics mesh new rectangle. We need the context, then a fill mode. This is what the different fill modes do. Stroke makes a nice outline, and fill, well, it fills the rect. I'm gonna use fill for now. After the fill mode we pass in the rect we made, and at last the color we want the mesh to be in. We have a mesh, let's draw it to the screen. The draw function takes the context and the reference to the mesh, and then we need some drawing parameters. Let's use the default parameters for now. We'll use this later to change the position, don't worry about it for now. Boom, we got a racket on the screen. It's a bit big though. Let's go to the top of the file and define some constant values. Racket height and racket width.
Rename the rect to racket because this will be our racket. Let's add 2 more constants. We need the racket height and width, but half. Let's set the racket dimensions using the constants we made. And the position of the rect will be offsetted by half of the size. This will offset the rect so the pivot point is in the middle. Wow, it's so tiny! Let's implement positioning of player 1 and player 2. GGEZ uses a library called nalgebra. It's a linear algebra library. Say that 3 times fast. Let's import the nalgebra namespace but rename it to NA. Ain't nobody got time typing out the whole name. Let's define our player's position in the main state struct. We'll use what's called a point2 and we'll be using floating point values to store our position. Since we added new data to the struct, we need to instantiate the data in the new function. Player 1 is on the left side of the screen, so the x position will be 0. But wait a minute. When we created the rectangle, we offsetted the position so the pivot point is in the middle. We'll set the x position to be half of the size of the racket. The Y position should be in the middle of the screen, so we need to get the screen size. If we look through the documentation, we'll find graphics drawable size. It returns the tuple with the width and height. I'm gonna declare some new variables here because we will need all of these later. Finally, we have the Y position of the racket, screen h half. Before we can observe this majestic racket, we added the context as a parameter for our new function, so we need to pass that in where we declare the main state. Player 2's position should be on the right side in the middle of the screen. Let's build. Oh my, nothing's new. Well, we aren't actually using these position variables. Finally, we get to use the draw params. Let's move it out to its own variable. We can use the draw param to define how things are rendered, position, rotation, scale, things like that. Documentation. I'm not sure why they call the position dest, but that's what we'll use. We'll set the dest to player 1's position. And I'm not gonna explain right now why we do this. I'm gonna do it at the end of this video because it requires a lot of explaining. Finally, we pass in the draw param into the draw function. Boom. Player 1 is drawn. Let's implement drawing player 2. Joink that, change the position, done. Let's add a ball. This code is going to be very similar to drawing the rackets. Set up the constants for the ball size. Make a ball rect and a ball mesh using the ball size. I'm gonna say balls a lot, aren't I? Add a position for the ball. Don't forget to declare it in the new function. And the position of the ball should be in the middle of the screen. Screen W half, screen H half. Let's draw the ball. Join the drawing code, change the destination to the ball position. And the mesh we are drawing is the newly created ball mesh. Bam! It's almost a game! Let's make things come alive. We're gonna add inputs. Let's add some namespaces. We finally get time to use the update function in the main struct. We're gonna check if the keyboard key W was pressed. Use the documentation. Use the documentation. When holding W, let's move the player up. We do that by subtracting 1 from the Y coordinates. Bam! Amazing! We are doing well, friend. Let's also move it down. Cool. We should use the delta time to make the movement frame rate independent. To get the delta time, there's a function for that. Pass in the context. Finally, we duplicate the speed with the delta time. But wait, this doesn't compile. The delta function doesn't return a float. It returns what's called a duration. At this rate, we are going to be experts looking at the documentation. To get the delta time as a float, duration has a function called as6f32. Now it works! We are using a hard-coded magic number, so let's move the player speed into a constant. I'm gonna make a function that returns a value clamped between a low and a high value. This will be used to keep the racket inside of the bounds of the screen. After the movement code, we can clamp the Y position. First I tried to clamp it between 0 and the screen height, but I realized the pivot point is in the center, so we need to pad these values by rack it height half. It works. Let's implement moving player 2 by copying all of this code, but changing the input and what position it will change. Not harder than this. But this code is a bit messy. It's not too bad, but a more elegant way to write this code could be to separate it into a function. Let's do that. Pass in a mutable reference to the position we will change, what key needs to be held to move it, the direction to move the Y position, and a mutable reference to the context. Let's copy some input and movement code. The input will now be from the parameter, the direction to move it is also in the parameter, and we are not modifying player 1's position, we are modifying, you guessed it, from the position passed in from the parameter. The clamping should also occur on this position. We are not done yet, we are missing delta time. Done! Now we can call this function instead of all of this code. Pretty clean, huh? Let's make the ball move around. We'll add a vector 2 to the main state called ball velocity, or ball vel. It's not a point 2, it's a vector 2. Let's instantiate it with some random numbers for now. In the update function we'll modify the ball position with the ball velocity. We need delta time though. Bam! That was easy. Let's add some variables for keeping track of scores, player 1 and player 2. It will be a 32-bit signed integer, and we're gonna instantiate them to 0. Start with 0 score. Let's create a utility function that randomizes the values of a vector. We'll use this to spawn the ball with a random velocity. It takes a mutable reference to the vector, and an x and a y value. We finally get time to use the ran library that we set up previously. I'm gonna implement 4 ways the velocity can be set. Either the x velocity is the x value passed in, or it's flipped. Same with y. First we need a RNG struct, and we can use this to get random values. Gen_bool gives us a random boolean. It takes the chance of this being true as a parameter, so we flip a coin 50-50. I'm gonna match the boolean returned from this value. If it is true, the x value is put into the vector. If it's false, the negative x value is passed into the vector. Same thing goes for y. So let's instantiate the ball with a random velocity. Does this work? Yeah, nice. The velocity speed is a magic number right now, so let's move that into a constant. Ball speed, yes. Okay, let's implement scoring. If the ball has a x coordinate less than 0, meaning it has crossed the left side, what should happen? Well, the ball should be put back into the center of the screen and the velocity is randomized. So let's randomize the velocity. Then we need to center it to the screen coordinates. We don't have those values right here, but we have done this before, so let's get the drawable screen size. Let's also check if the ball has crossed the right side of the screen. Does this work? Yes sir! If you remember, we already added player 1 and player 2 variables to the main state. So let's increment the player score. If the left side is crossed, player 2 gets a point. If the right side is crossed, player 1 gets a point. Let's add a score text to the screen. GGEZ text new. The format macro is very nice when, well, formatting strings. This bracket will be set to player 1 score and the right bracket set to player 2 score. Let's draw this to the screen. Pass in a reference to the score and the draw params. And here is the danger of reusing the same draw param. The destination was last set to the ball position. That's why this happens. Let's change the destination to be in the middle of the screen. Drawable size, we meet again. That code session was a bit messy. Let me pause for a moment so you can check it out. Whew, we're moving fast. Alright, scoring done. Actually, I want the score to be a bit higher up. Since we are only going to need one of these, let's remove them and only use the width. We're gonna get the tuple with the index 0. That's the width. That's what you can do with the tuple. If you look closely, the text position is skewed. It's not perfectly in the middle. That's because the pivot point is in the upper left corner. We need to offset the position with half of the text size. To get the text size, the text tract has a function called dimensions. It's a 32-bit signed integer though, so we need to convert it to a 32-bit float. Since we mutate the text position, the variable has to be mutable. Now the text is in the middle of the screen, but a bit higher up. Honestly, we're almost done. There's not much to add. If you made it this far, good job. I know I've been moving a bit fast, but I don't wanna make an hour-long video. Anyway, let's continue. Let's make the ball bounce against the ceiling. If the ball's Y position is lower than half the ball size, we are touching the roof. To make it bounce, we will ensure that the Y velocity is positive, using its absolute value. If the ball's Y position is greater than the screen size minus ball size half, to make it bounce, we need to make the velocity negative. We can get the absolute value of the velocity and then, well, make it negative. Cool! As a safety measure, the ball could clip into the bounds of the screen, so let's make sure the ball's Y position doesn't. The last gameplay mechanic to implement is making the rackets actually bounce the ball back. First, let's check if the ball touches player 1. Explaining this can be a bit tricky, but first we are going to check if the ball's X position is within player 1's racket. We do so using the positions and the sizes of the rectangles. Okay, so if the ball intersects with player 1, the ball's X velocity should be forced to be positive, so it goes to the right side. You know what, I wanna move the pedals out a bit. Let's declare a new constant, padding. When we instantiate player 1 and player 2's position, let's modify the X position with the padding. Ah, much better. Let's give player 2 a chance as well. I mean, only player 1 can actually defend its goal right now. Join all of the collision code and change the player's position to well, player 2. And the velocity will be set to always be negative, so it bounces back and goes to the left. That's Pong! We did it! As an extra, let's add a middle line. Add a constant for the width of the line. We're gonna create a rect and we will offset the X position with half the width size. Set the width and set the height. The height will be the screen size. Create a mesh using this rect. And now we're gonna draw it, but the position should be in the middle of the screen. Boom! We did it! That's the tutorial. Good job. If you actually made it this far, that's for you. That's for you, my friend. I said I would explain why we call into on the positions, but this video turned out to be much longer than I thought it would be, so unfortunately I'm not gonna cover that today. There's also a bunch of small code things that can be improved on. I just realized you don't need to generate a mesh, you can just call graphics rectangle. Also, we are generating a mesh every draw call, which should be avoided if we can, and we can. Hey, you can figure that out yourself.
Use the documentation.
This game actually took me about a day to program, so don't think I'm some magical wizard programmer who just touches the keyboard and made this thing magically come together. I constantly had to check the
documentation.
Some of you might wonder how I approached making this project. How do I learn a library like GGEZ? As with any Rust project, the first thing I always do is to jump over to the example code. Even in the documentation, sometimes there is example code. Those have been my biggest resources of learning how to make things like this.
Use the documentation.
Hey, if you learned something, or if you just appreciate my videos, don't forget to leave a like, subscribe for more game development content, and give me some feedback in the comments. This has been Tantan, and I'm out. Whee!